Hello YouTube, it's Hamster Boy on the Fajuff channel, and this is brought to you by Snap Circuit. Snapping electronics every day. Okay, yeah, that was my fail of a new slogan for Snap Circuits. I don't know where that came from. But yeah, so here's a new circuit I made. Beautiful, isn't it? Remember that other circuit I made in the previous video? Well, that was a test circuit, idea concept, basic what I think, testing what I can do with the components I got, and seeing their capabilities. It's a test. What more do you want? So, yeah. Anyhow, so I integrated that test idea into a much larger, more complex circuit. As you can see, this is quite complex. I'll do a slow turnaround for you. And yes, I will also go all nerdy, because you like that so much, and show you more detail of how the circuit works. Now, granted, this is just a test circuit as well. Or, actually no, this is a final circuit, but it's built like a test. So, I never turned the power on yet. Basically, this is going to go on the back of Snap Circuit RC Rover. I'll show you that now. Here's the Snap Circuit RC Rover. Snap Rover. Snappy name. Doo-doom-ch. So, yeah. It has gears inside. They spin. Whoopee. This is fun. Not really. Though I do like my gears. And so, this device just, yeah. There we go. And, yeah, like that. Just like that. Ta-da! Okay, yeah. I don't know why I repeat myself like that. It's just weird. Okay, so, if any of you think this is overwhelming, raise your hand now. On second thought, I can't see your hand, so if this is overwhelming, let me either explain or confuse you. First of all, as any of you owners of the Snap Rover know, the rover body contains the source of energy, the battery. You have 4 inputs. I know it looks like 8. I mean, you have 6 inputs opposed to 8. These 2 are dead, idle. They don't do nothing. They do BS. This is your positive. That's your negative, I believe. Or the other way around. This one is left forward, left back, right forward, left back. Oh, no, there. Right forward, right back. Left forward, left back. These 2 don't do nothing. So these 4 control the 2 motors. These 2 are for the batteries that are housed within the body right under this panel. Okay, glad we got that established. Moving on. So we hook it up using cables, and where this one snap is, there's supposed to be a cable running from the positive lead of the rover body. Then we have a switch, and that then follows along this path underneath this part. Okay, following me, camera guy? Then it comes here to this relay, comes along to here. Okay, notice which way the green arrow is pointing. It's pointing here. That then powers the RX1. I love that name. And the U8. components. Now if I twist it around, it also comes over and powers, that's a R1, okay, 100 ohm resistor, and it powers this black LED. Or no, this white LED. Listen to me talk. Black LED. Derp. And then comes back to the RX1. So this is under the right trigger. When I pull the right trigger, power comes through, goes through that, goes to here, then goes through the negative. Here's a negative for that. Now, like I shown before, when the photoresistor, I used a switch before. I replaced that with a photoresistor. The photoresistor is hooked up to this red wire. Ignore this piece because this is part of the positive power. Okay, so it comes through this red wire, comes to this, the Q3 SCR gate. Basically, it allows power coming through this wire to travel to the coil of the relay and flips it from here to here. So power is going through here, flipping that. So as the power comes through here, it goes up and over, around this way, and all the way back to negative. Meanwhile, now that the positive power is coming this way, it doesn't power this, it does not power that, nor does it power that. Instead, it goes through that R3 5.1 ohm resistor and to this red LED. Now, you're probably saying to yourself, it's pointless putting an LED underneath this wire. And you're right, it is. It is pointless. At the same time, you're saying, it's pointless to put this switch at the back when these are supposed to be tanks. Oh wait, was I not supposed to say that? Anyhow, these are supposed to be tanks, but as you can see, I kind of ran out of room to put everything on one board. I could fit it onto two, but that's sort of cheating the system, and I want to make it feel complex and integrated. Small, but complex. So anyhow, the power goes through the red LED, and it then goes up, over, and then back to ground. So basically, by letting power come through the coil, the coil of the relay, that trips this and diverts power from the main unit and forces it through the red LED, which means all systems will fail. You won't be able to drive your tank, you won't be able to fire your cannon. Basically, the machine shuts down, and the red light turns on, indicating that it is not working anymore. Now, there are a few things I wished I could have put on this circuit. Granted, I have not yet tested the circuit, but there are a few things I want to put on the circuit. First of all, a green indicator light, representing that the unit is on. Second of all, I wish that I could put a delay on the light. Right now, you could just hit the button and keep holding it or rapid fire the button. Rather, I wish you could tap it and then wait a while before you tap it again. Oh well, I'm running out of time. This has been Hamster Boy on the Fajuff channel, signing off with another nerdy circuit. See you later, folks. Nom 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 nom. Diggy diggy hole. Portal out. Cake.